Hello there, geometry students. It's Mr. Rising once again. I'm starting to feel a little sick, so I thought I'd better get some lectures posted for you, just in case I'm not here, or you're not here, or you missed something and you want me to see it, go over it again. This is lecture 3.6. It's about graphing lines, writing their equations, and then classifying them, whether they're parallel, intersecting, or coinciding. I'm going to make another lecture on the true geometry standard that you're trying to master. And these can be very lengthy problems, so I'm just going to make that a separate lecture after you get through this one. Sound good? Good. So you will recall that there's actually three forms an equation a line can take. There's standard, which is ax plus by plus c. There's point slope, and there's slope intercept. I'm going to start at the bottom here because it's just easier this way. So the equation of a horizontal line is always y equals the y-intercept, right? Because if you draw that horizontal line across, it means that all points, the y value doesn't change. The reason you can't use point slope or slope intercept form, the equation of a vertical line is the slope is some number divided by 0, and you can't divide by 0, so that just wipes everything out. It gets really messy. So long story short, the equation of a vertical line is x equals whatever the x-intercept is, and then you have a vertical line through that x-intercept. For example, x equals 5. Now you're most familiar when we talk about graphing lines and whatnot with something probably slope-intercept form. And the reason this is so popular is you look at it and say, oh, the y value is equal to the x value times the slope plus b. What's b? Well, b is the y-intercept. B is actually a point. It's the point where x is 0 and you get a certain y value. And here's an example. Y equals 3x plus 6. M is 3. B is 6. And a reminder just popped up. Warning, warning. Snooze it. Snooze and go away. Hey, go get out of here. Bye. Come back tomorrow and fill out an application. The last one is point slope form. Y minus y1 equals m, the slope, times the quantity x minus x1. Now the key here is, warning, warning, warning. Notice the form minus the y value minus the x value. That means if you're given a coordinate and it's positive, it will look like it's negative because you're going to subtract it. And if it was negative, like negative x1, negative y1, then these would look like positive y plus y1, x plus x1. When I was getting ready for this lecture, I saw, wait a minute. Look at the example. Pause the video if you need to see if you can find anything wrong. Poof! Welcome back. Yes, correct. You did identify it. When you look at these values, why did they put the 3, which is the x, over here with a y? You're right. This is an error, and you just caught it. So to correct this problem, we're going to scratch that out. I know it's very technical. I think you like my lingo there. And really, this should be parentheses 4, comma 3. Anyway, good. So now just copy that example down. Let's carry on. Right? I've already reminded you that a line with y-intercept has a point B, and that's 0b. A line with an x-intercept, A, contains the point A0. Okay? So where does point slope come from? If I gave you 2 points, could you prove the form? Well, you know what? We'll handle that another time. But the key here is, from any 2 points, you can derive the slope. All right, let's check this out. Write the equation of a line in the given form. So it says, I'll give you a form. I'll give you a point information. You put it together. It says the line with a slope of 0, and it goes through a point, 4, 6, in slope-intercept form. That's easy. Why is that so easy? Well, any line with a slope of 0 has to be a horizontal line, which means this problem is just a simple y equals y-intercept problem. All right, well, what's the y-intercept? The y-intercept is also right here at 6, which means for all values of x, y is equal to 6. Sweet. Again, pause me, rewind me, do what you need to do. The next example is a little harder. It says, find the line through these 2 points in point slope form. So we need to actually walk through this process because these problems can take a while. The first thing to do is find the slope. Then you're going to plug in that information into point slope and slope intercept form. All right, here's my formulas. I don't have the fancy function key, so just get over it. I plug everything in. Y minus y1, x2 minus x1, and you'll notice, wait a minute, they both have the point, the y coordinate of 2, which means this is also a horizontal line. Oh, sneaky. So you know your slope is 0. All right? Well, now go back to your point slope form, set it up, and then plug in what you know. I chose to take this point here, 1 for x1, 2 for the y1, and you end up with 0 times anything, of course, is 0. Y minus 2 equals 0, which means y is simply 2. And you can see that right there. All right, team, here we go. Graph each line. What? Graph each line? Well, in case you forgot how to do this, and some of you may have forgotten how to do this, if you don't remember how to graph something and look at it quickly, what you can do is make a table, plug in x values, put them through the function, and you'll get out y values. So here's what I mean. I'm going to plug in 0 into x. 0 times 2 is 0, minus 3 is minus 3. I can plot that point. Plug in 1. 1 times 2 is 3. 1 times 2 is 2, minus 3 is 1. Plug in 5. 5 times 2 is 10, minus 3 is 7. All right, so I can actually plot these points out. Let's do it real quick. And you'll say 0, negative 3, 1, 2, 3. 1, negative 1, 2, and 5, 7. 3, 4, 5. 7's got to be about there. And I can make a line through them. Now, the other thing I just want to point out real quick is, if you do recall, this is slope-intercept form. My intercept is negative 3. I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up, and of course, they're all on that line. So let's just plot it out. And again, the sound effects make it more fun. I'm 7 minutes in. Got a few slides to go. We're going to wrap this up. Now, in this one, it's a little more complicated, but you know what? You can still do it. Don't freak out. The key to this problem is recognizing it is point slope form, which means I'm giving you a point. What point am I giving you? x1, it looks like plus 2, which really means it's negative 2. Let's do it. And then my y coordinate is just going to be positive 1. I said, what's the slope? First thing to start with is the slope, negative 2/3. What's the point? And again, the point is negative 2, 1. Excuse me. Oh, poor Mr. Rising. I'm dying up here. All right, so let's start with our point. Negative 2, 1. Negative 2, 1. Boom. From this point, I'm going to go down 2. 1, 2, over 3. 1, 2, 3. The key here to remember is we're always going left to right. Right? If you're going positive or negative, up or down, you're always going left to right. Then I'm going to take this and just extend it through it. Right? I'll go like that. And then if I need to, I can extend it the other direction as well. Like that. Boom. Sweet. All right, craft this line. Y equals negative 4. Well, wait a minute. Negative 4, is that vertical or horizontal? Well, the y is negative 4. Well, that means every y is negative 4. Oh, right. So that's a horizontal line. It has a slope of 0. Boom. Just like that. Hopefully this stuff should be review for you. All right. So now a system of two linear equations with two variables represents two different lines. They can be parallel, they can intersect, or they can coincide. If they intersect, of course, then they could possibly be perpendicular. And we're going to get into that in a little bit. Lines that coincide are exactly the same line, although they may look different at first. So this is a graphic that really puts it all together. Again, parallel lines, same slope, different y-intercept. Intersecting lines simply have different slopes. They're going to cross somewhere in a plane. Right? Skew lines are two lines in different planes. Hold on. Wait, you can't see what I'm doing. Hey, there it is. Hey, there we go. Right? And coinciding lines are the exact same equation, although it may not look like it at first. Check it out. Determine whether the lines are parallel, intersect, or coincide. So step number one, let's get them in the same form, right? And that's really important. And I always like y equals mx plus b. So what I'm going to do is I'm going to solve each equation. I'm going to figure it out. On this one right here, all I have to do is divide both sides by -5, and it's already simplified. This one, I have to move the 3x to the other side by subtracting it. But when I do that, I get y equals -3/5 x plus 2/5. This one is y is -3/5 x minus 6/5, which means they have the same slopes but different y-intercepts. Therefore, the lines are parallel. Team, this is my last slide, so hang in there. Erica's trying to decide between two rental car plans. Ooh. Right? Rental car plans. Okay, makes sense. How many miles will they be the same? What you're really saying in this problem is, where are these plans equal? Therefore, set the plans equal to each other. And hopefully this is where you're saying, hey, plan A is 100 plus 35 cents a mile. Plan B is $85 plus 50 cents a mile. When I set them equal to each other, and I do the algebra, and I know it looks kind of crazy, I'm combining everything at first, but I'm taking the 85 and subtracting 85 from both sides to get my dollars over here. I'm subtracting 35 cents per mile from both sides to get my variables all on one side. You'll notice then that $15 equals 15 cents per mile. That means when I divide 15 by 0.15, I get 100 miles is the magic number of miles when both plans are the same. I hope this lesson helps. As I said, I'm going to post another lesson when it gets a little more complicated, but I wanted you to have this basic information about lines that are parallel, intersect, or coincide.